It's the Packet Thrower! Welcome to the channel! Hey guys, we're going to pick this up where we left off there. We just finished the basic setup in part 1 of this video. And in this video, we're going to focus on the VTI side of things. So a couple changes since our last video is that I went ahead and added another network there so we can simulate an MPLS. So we have more flexibility for VTI routing. And then I gave the internet an actual router. So I connected an AK router here just so I can do NAT and get things actually online. And everything else is the same. So what we want to do is head over to interfaces, and then we can add a VTI. We can also add sub interfaces if you want to do VLAN tagging. You can do bridges if you want to do bridging. And VNI is another new feature where you can start doing VXLANs. Right now it's only for cloud only deployments, but they're going to be making it on-prem soon. Anyway, we'll go here. And we're going to give this a name. This can be any name you want. I'm just going to pick DC1 to DC2. Give a description if you care to. And we're going to go ahead and create a zone. Let's call this VTI. Now we can mess with priorities, whatnot, if we want to have a bunch of VTIs and how things are allocated. We're just going to leave that as is. And we're just going to say that the VLAN ID, or tunnel ID, excuse me, is going to be 10. And I'm just going to go ahead and say 10.255.121.1/24. For the tunnel source, this is going to be my outside. One other change I forgot to mention is when I added the MPLS is I moved the interfaces around. So the first one is the internet and the other one is the MPLS. We'll just say this is the internet link. If there's multiple IPs, you can select it, but it's just the one here and we're good to go. Now what we want to do is add 2 tunnels. So we're going to say that this is primary. And then we're going to add another one. Call this here. We'll say this is backup. We're going to use the same zone. This tunnel ID can be 20. And what we're going to do is just go ahead and pick another range here. So it'll say 10.255.122. And this is going to be our MPLS link. And you can see that this is the range I picked. So we're just going to go OK. Okay, we'll save that, and then we will head over to the other one and do pretty much the same thing. This would be the VTI, 10. These don't have to match, by the way. You can do whatever numbers you want. And then this was 10.255.121.2. Oh, no, that one. And then we want this one. Actually, you know what? I'm going to make this 21 and 21 because we have high availability in the other node. Let me just make a quick course correction here. And what we're going to do is just change the IP address there so it fits my standard better. So we're just going to say that this is 11. And 11. This is just for my consistency's sake, but we don't really need to do this, but why not? And then we'll go to high availability, and then we will put this to be 12. Okay, now our VTIs are defined. Now we actually have to do something with them. So we're going to go to site-to-site VPN. And we're going to go ahead and add a threat defense. And we just give this a name. We'll call this DC VTI. And it's going to be a route-based VPN. You can do like version 1 or 2. I'm just going to leave it at 2. And we'll say that this is the first device. This is the primary. And then we're going to add a backup VTI. which is going to use our backup path. So this basically means that's going to find both the tunnels for us. And then we're going to allow on routing to do failover. So this will be DC2, primary, and secondary. Oops, there. Okay, so for the X stuff, for the X settings, I don't really care too much about the VPN. I just want to get the VTI up and running, so I'll just leave the defaults. But notice that Firepower will automatically generate a pre-share key for you, and then you don't have to worry about making your own key. So that's kind of a nice feature. IPsec, again, we'll leave it the same. I will turn on perfect forward security though. And then for our traffic there, you can see that we can't bypass the traffic for a VTI. We must deal with it in the role set. So if that's done, we'll just go save. And then we will go to our rule set that we created in the last video. And we're just going to add a global rule for our VPNs. We already have one that allows routing. So what we're going to do is just edit this one. And we're going to say that if it's inside our VTI, it can go to inside our VTI. So that's good enough for us right now. And then what we're going to do is just add a simple rules there so traffic can go in and out of our VTI. We're not really concerned about locking things down for these videos. So we're just going to say allow VTI inbound. We'll say anything coming in from the VTI is perfectly fine. And then we'll just make one for the opposite. Let's say the inside is allowed to go to the VTI. All right, good enough. So we'll go save. And then before we push the rule, we also want to make sure that our NAT is sorted out. We already have a rule that allows the internet traffic, which basically says that if it's going from the inside to the outside, then just put it on the outside interface. What we need to do is tell it to not NAT the VPN traffic. So what we do is go add rule, manual NAT, and what we'll do is just say from inside to internet. We want to say that the source is just going to be all our private ranges, and the destination is going to be the same thing. So basically any private IP to any private IP, which is typically what you expect on the LAN. And then all we do is just say the same thing here. So what we're doing here is we're just going to say that if it's a private IP going to a private IP, leave it alone. Now under advanced, we can choose to say perform a route lookup on the destination interface there, and that's just going to make sure that it routes properly. And we don't need to mess with anything else. We're just going to go OK. And then we're just going to do the same rule for the MPLS interface. I'm just going to go copy and paste below. And all I do is just go here and say that this is the interface. Now, we don't need to make a rule explicitly for the VTI because we don't have any NAT rules that would hit the VTI interface, so we don't need to worry about that exception. But we could have one if we wanted to. All right, so with all that done, okay, so now that's done, we can do the other side. I'm just going to pause the video here, and then I'll get back to you on the other side. All right, that's done too, so we can go ahead and push the rules. Okay, so now I should be able to go to the site-to-site here. And if I check the status, we should see that our VPN is up. We can see that we have both sides of the tunnels are green, and we can see the various VPN information. And we should see our other tunnels up too. At this point, we have a VPN, but we need to add some routes if we want to actually pass traffic through. So we'll go back over to our device management, and we'll go to here. Inside of routing, we have a few options here. We can do a static route, we can do a policy-based routing, or we can do BGP. Let's have a look at each of them. So for the first one, static routes, they really aren't that interesting. All you do is you would select which interface you want to route out of. You would pick the networks that we want to reach. And then for the gateway, we would just go ahead and enter in the gateway. I'm not going to bother with actually doing the static routes, but that's the basic idea. The only thing of note is if you wanted to do load balancing between the tunnels and whatnot there, you might want to consider doing the equal cost multipath routing, ECMP. And that way the firewall knows to treat the interfaces the same so it won't drop asymmetric traffic. But what we're going to do instead is play with policy-based routing. So we can go ahead and add a role. By the way, we can also choose to add interface priorities there if we want to order our interfaces that way. We're not going to bother with this. We're just going to go add and select an ingress interface. This is going to be inside from PPR's perspective. And then we'll go add. And we need an ACL to match. So I'm just going to go ahead and create one. And we'll just call this ACL PBR lab. And then from here, we add an entry. And from here, we add an entry. And what we're going to say is from DC1 to DC2. It's good enough for me. And we're going to just go ahead and use a single ACL. So we're going to use that override feature I've mentioned a couple times. And we're just going to say add. We choose which device to add. So it's going to be DC2. I didn't mean to hit enter there. Let me just go back. And we will edit this entry so that it is the opposite. We will go DC2 to DC1. And save. Okay, so we can see that on DC2, we're going to do an override. So we'll go save here. Now we have our ACL set. We could choose how we're going to do traffic. We can send by egress interfaces. So this is where we would say like we want to do the primary and then the secondary. We're just going to keep things simple and just do it by IP address. So we'll just say IP address. And one would be 255.121.21 and 122. We'll just go save here. You get a nice little summary of what we're doing, and we'll save. So now that's done, I will go ahead and do the other side. And then for the other side, all we need to do is change the IP addresses. They'll be 121.11.122. That looks all right. So when I push this, we should have a working PBR. Okay, now that that's pushed, you can see that my desktop in DC1 is able to ping DC2 across the VTI, and we're using PBR. We can prove it by going to our command line and using packet tracer to say something from the PC going to the other PC is routed through the VTI. And if we scroll up to about here, we can see that PBR is one of the first phases. Well, it is the first phase, phase 1. And you can see that it is matching and changing the next hop. And then if we work for all the way for the logic here, we can see that it's sticking with that next hop. So that is working as intended. And that is PBR in a nutshell. I'm going to go ahead and clean this up, and then we'll finish up the video with some BGP. Okay, so that's been removed. So let's finish this up with some BGP. So under our routing here, we can see we have our various routing protocols. EIGRP is still not here, but I'm told in the next release it's going to pop up here. It's still in the flex config land. But for our VTI, we want to use BGP. So we're going to click on here. And this is where we do our global settings. So we'll enable it. And we're just going to go ahead and do internal BGP for this. We'll say 65123. And we'll just leave it automatic for the router ID. In terms of our settings here, we can customize how we want routing to work and all that. We're just going to leave this all pretty much the same. And then we'll just go to IB version 4 here and set up our neighbor options. So first we're going to enable the family and define a neighbor. This is going to be our first neighbor. So it's going to be 255.121.21. See, it's enabled. You can give it the same ES because we're using internal. Give it a description if you want to. And what we're going to do is just keep things simple for right now. So we'll just go ahead and click OK here. And then we're just going to use redistribution to get some routes inside the BGP. We'll say connected can be 100. We're not going to bother route maps right now. And OSPF. So 100. And we're going to match internal and any external routes. So with that done, we're just going to go ahead and add the other neighbor here before I forget about it. 2221 enabled 65123. Yeah, that's all fine. So let's go OK here. And before I forget, we're just going to go to general here and then make sure we say that we are going to allow BGP to be redistributed into an IGP, which is just a loop prevention mechanism. So that looks pretty good to me, but we also have to do OSPF. So we'll go here, go to redistribution, and we're just going to say if it's BGP, use subnets, we'll give it a metric value, and we're just going to use type 1. You can also take a 2 if you want to. It'll say this is 100. Actually, that should be 200. All right, so we'll save that one. And I'll do pretty much the same thing on the other one. So we'll go to BGP, enable 123. Make sure we can redistribute. Set our neighbors. 5, 1, 11. And that's good enough. We will redistribute connected. OSPF. And then we want to do this guy here. I'm just going to say BGP, use subnets. I think I used 1000 on the other one. Type 1, and this will be 100, basically just tagging the data center where the routes come from. Oh, and 653. Okay, so we should be okay here. So we're just going to go save. And I'm going to deploy this bad boy. Okay, with that done, we should be able to test out our BGP. So let's just go over to our command line here, and I should be able to go show BGP. You can see that I have learned the other site's routes. And we can see that because we haven't done any route maps or anything like that there, it's just learning both sites and picking what it feels is the best one. Here's what the tag. We can go ahead and look at a particular route here. So if I look at this guy, for example, You can see that the tag is here, and I can use that for redistribution or some other policy thing down the line there. Just a handy thing to do when you're messing with redistribution across different networks. All right, so we should be able to be pinging from our desktop. So let me just pull up the VM here. Yep, so that is pinging just fine. So the last thing we'll do is just add some route maps to the mix there, just so you can see what that looks like. So if we go back to our trusty routing tab. All right, so what we're going to do is we're going to prefer the primary VTI over the secondary, and we're going to do that just by adding some local preference. So we're just going to edit our neighbor, and then we're just going to go to route maps here. We will call this RM BGP primary. And we'll just give this a sequence. Everything's going to match by default, so let's go to set, BGP, others, and we want local preference. So it's going to say that the primary is 999, so it stands out. And we're going to apply that to the incoming so that any routes coming in will have that applied. And then for the secondary neighbor, we'll create a route map. That's pretty much the same thing, except for we're going to have a lower value. So we'll just say 10 again, set, BGP, others. Just say something like 321, doesn't really matter, as long as it's a lower value. And we'll go OK. I'm just going to go ahead and save this. We're just going to do it on the one router, not the two, or firewall. Well, it's basically a router at this point. So now that's done, we should be able to check BGP again. And we can see we have 999 as a local preference. And we are not seeing the other one there. I bet you I forgot to apply it. Let me just go back over here. I did. All right, so there's the backup. We'll just run that one more time. All right, let's try that again. We'll go back to our FTD. And we're just going to hook things along. We'll say clear BGP, soft. There we go. All right, so that is VTIs in a nutshell. Go a bit deeper into the routing side there, but for the next video, we'll talk about some of the more automation stuff there. We'll look at dynamic objects and the secure dynamics attribute connector. So it should be a lot of fun. See you there.
Hey! So what are you up to, Mason? I was gonna just... Oh no! The birthday bag.
It's in the hermit cap.
And it is going to further insert himself. Like, ah. And it's going to further insert himself. Oh, I was able to get himself out. Ah, cute. Oh, good job, Mason.